Breaks one tap, breaks another one. Now he's in the open. 40, 30, near sideline. Flicker to get the nice from 50, 10, 5, touchdown, touchdown. Left, snap it to Michelle. He's running to the left, angling 25-20. Got a block from 50, 10, 5, touchdown, touchdown, touchdown. Dogs win it. We're headed to Atlanta.
First.
Yeah. And it drops down. And I don't know how long we should make that hole. Like,
As dimensioning.
something cover up. Like, I don't know, we could like paint this or something. These little things on the side.
Here at the University of Georgia, we're all about success and excellence. In anticipation of this year's national championship, we decided to build our own miniature national championship trophy. Brian here is staring at the trophy with envy as he knows the Dogs will bring it home this year. The design was made in AutoCAD in two parts. The top would be the championship trophy and the bottom would be the base. The base was printed in a MakerBot using POA plastic. While the base for the trophy was made using additive manufacturing and material extrusion, the trophy itself was made using subtractive manufacturing with an ABX50 with a rotary axis. Horizontal milling was employed in order to shape a block of wood into the national championship trophy. Constructing the base itself was not without its own issues. Originally, the CAD file that we were trying to use with the MakerBot kept getting corrupted, and we had to go back and redesign the base 3 times because we could not use the file. In addition, the MakerBot originally said that we had a filament height of 0 millimeters, but we got that issue worked out. The milling process itself took roughly 6 hours and was not without its own issues. Originally, the CAD file we were trying to use was incompatible with the MDX50, and we had to go back and find out what CAD file we were supposed to use. After that, we found out that the milling machine itself was actually not functioning, and had to employ the help of the college in order to get it back up and running. Once both of these were accomplished, though, it was a very simple process to turn our cylindrical block of wood into a trophy worthy of a champion. After the original manufacturing processes were complete, both parts required finishing. The base needed to be sanded down, and the trophy itself needed the excess wood to be cut off, and then sanded some more.
This is what I like to call the extreme nail pattern. When you agree.
We made a slight error in calculating the diameter of the hole in the base and the diameter of the base of the trophy. And in order to correct this, we sanded down the inside of the base itself in order to widen the hole, while simultaneously sanding down the bottom of the trophy so that it would fit better into the hole.
Nice.
Finally, we had to sand down and finish the top of the trophy and other design. We did this by using a Dremel and various size bits.
How's that heat transfer homework coming along, Rach?
Terrible. I got a 32.
It's all about the fine details. Here, to finish up the trophy, we're adding the stitching to the top to make it emulate the actual trophy even more. Finally, after hours of work and some acrylic paint, we brought the Natty back to Athens. We learned a lot about the machines we used during the course of the project. While most of us had used a 3D printer before, none of us had ever used an MDX50. One of the biggest things we learned about the MDX50 was that much like a MakerBot, it also uses supports during the machining process. As a result, fine details such as the stitches in the top of the trophy had to be put in manually, because the machine could not do it. In addition, the machine was unable to machine out the whole top of the trophy because of the supports, leaving a lot of excess material to be sanded off. If we did this project again, we would definitely take that into consideration and focus more on making sure that we can machine the general shape of the trophy instead of finer details we can do by hand. We tried to have the MDX50 do everything, which was the biggest mistake. Another thing we learned was that the machine oftentimes drew too much current, which would cause an emergency shutoff. To remedy this, we lowered the amount of wood removed with each pass to keep it from shutting off due to current spikes. The constant shutoff delayed the project, and had we originally started with a smaller amount of material for each pass, it would have been a quicker process. Also shout out to Brent Schubert for helping us fix that problem.